Good morning, everyone. Thanks for being here. Basically, I've been working on wave energy since '78 and started it in school. And the idea was ultimately to come up with renewable energy, but at the time it wasn't so much about things like hydrogen production. And over the following decades, things like hydrogen have become more important. There have been people putting forth these proposals for many, many years, and I always think if we had followed some of their dreams instead of the hydrocarbon economy, maybe we would not be in the climate and waste management problem in which we are today. So basically, this is an example. It all started in US with the development of oil and gas. And we are to blame for bringing that technology to the rest of the world who has embraced the use of fossil hydrocarbons. And at this point, we really have to deal with some rapid changes. I started noticing these difficulties as a child growing up outside New York City. But obviously, this has spread as industrialization has spread to Asia and India and other parts of the world. So at this time, China will be overtaking the US by 2017 with oil imports, sort of continuing this chronic habit that we're in. And just now beginning to recognize some of the environmental damages that are occurring that have very true costs that need to be accounted in the bottom line of how much it costs to provide energy for human functions. So everybody here, I'm sure, has seen some of the work done by climate scientists. It's been obviously argued about, but it's very emphatically so that things are changing rapidly, especially with respect to long-term observations. My concern is more specifically toward what's happening with ocean water. And basically, what we're seeing, as you might know, are the melting bergs are raising sea levels. They're changing salinity gradients in the ocean, changing thermal cycles and actual large-scale current movement throughout the world's oceans. However, some of the symptoms are the melting bergs, and that's basically the deposition of fresh water into the salt water, and it is raising sea levels. When I started this project in 1978, I used to worry about whether my device, which is electrical producing, and ultimately trying to desalinate ocean water and then produce hydrogen and oxygen gases from it. I used to worry that I was going to lower sea levels on a very large scale. I'm really in the belief that the module, the basic unit, when expanded in numbers, if it's a good module, the results will get better. If it's a bad module, the results will get worse. So I'm trying to concentrate on a minimal systems approach that in itself, when submerged in the ocean, would not raise sea levels. But the proof now is, at this time, all of the Earth's ocean waters are raised the approximate height of a Chinese teacup. That, optimistically, is our next fuel. If we can sequester water in the form of hydrogen and oxygen in our industrial and automotive processes and other human functions, it's actually almost like a gift meant to be. So some approaches to wave energy conversion tend to be shore-based. People stand at the shore and they see the power of the breaking waves. They swim in it, they get hurt by it, and that's fine. However, the shorelines are some of the most delicate ecosystems in the world. And we've already imposed our humanity on the land side and devastated certain coastal regions. And so if we are to apply wave energy converters directly on the shore, we have a potential to upset other natural cycles. In fact, anything we do as humans tends to be at odds with natural cycles, so that the quest is to minimize our perturbation. So some of China's wave energy converters, I call them one-off devices, which means that they are unto themselves. They're built individually, they're towed out to a site individually, and then deployed and maintained. They each have their own anchorage, and that adds to the costs per unit. Because waves are very diffuse, they're very powerful, but it's a diffuse wave field source, I believe we should have more of a modular, self-supported approach. So in 1978, I invented a wave energy converter modular system with a linear electrical generator. And basically, a week after inventing it, I was in an accident with carbon monoxide poisoning that killed my passenger, almost got me. So I dedicated my life to providing renewable energy and hopefully hydrogen-fueled cars where the exhaust is water. So in this way of rising sea levels, we can actually sequester that extra water in our functions, and it could be a very elegant solution. What's gone on in my little field of marine hydrokinetics are several copycats over the years. These are some of the copies of my linear electrical generator. Some are put on the sea floor, others put in devices that are, again, non-modular. I think there's room for efficiency. In fact, there are now over 175 wave energy companies. When I started, there was only the one I founded. And it's akin to the early days of other technology developments. Everybody's tripping over themselves. There's a lot of mistakes being made, and my big concern is leaving too much waste in the ocean from the failures of the failed experiments. So I've been working with some governments to come up with an organized way to foster wave energy. And in the United Kingdom, they have a great idea of something called the Wave Hub, which is a government-provided socket in which developers can get permission to plug in their various experiments. So they don't have to take in the cost of the peripheral technologies that prove out their ideas. And the government can basically manage the site to keep it clean and organized. Also, they can get relative data of the various different devices and have a much better way of comparing them. So in the US now, finally, there's a Bureau of Ocean Energy Management, and they're establishing an East Coast Wave Hub and a West Coast Hub. And they're zoning certain areas for individual developers to have particular site access and not really be disturbed by other developers. And so other industries are getting interested in this, and you can see on the right side the 12 industries. But a lot of them are slightly adjusting the design of their components to corroborate with this new industry, and it's actually very exciting. There's a lot of great dialogue going on. Some of the first people who they go to the beach and they look at the waves, they might go swimming and get knocked over by a wave and say that's very powerful. So many of the first developments were onshore, nearshore deployed devices, which I vehemently disagree with because the shoreline is one of the most delicate, interactive areas where nature needs to have basically a freedom. We've already encroached on the land side with much development near shore. So I feel also that the waves breaking on shore are actually losing their energy. So I've always been going offshore, and that's an area where the waves are much more energetic, but they're a little more complex. They arrive from different directions, and they form varying shapes that are difficult to model and also to academically describe in terms of conversion to electricity. So basically, following the teachings of a man, Buckminster Fuller, I don't know if anybody in this room's heard of him, but he was a great thinker. He came up with the word synergy, and he was all about efficiency and doing more with less. He invented the octet truss, which is the basis for my system. He's had the carbon-60 buckyball named after him, a shape that he saw back in the 30s. He invented that Dymaxion map, which you'll see later, that's 5% distortion from spherical reality. Very practical ideas that need to be used much more in the world. This is a little movie.
Ocean Wave Energy Company's OEC is a device that efficiently converts the kinetic energy of ocean waves into electricity. Each OEC module consists of 3 buoys, which are directly connected to a generation and control section below the water's surface. As the buoys follow the contours of incoming waves, vertical motion is converted to rotary motion, which is utilized to spin onboard electric generators. The generation and control section also contains flotation chambers, which allow the OEC to maximize its conversion efficiency according to prevailing wave conditions and to protect itself from damage when seas become rough. When several OEC modules are connected together in an array, an extremely strong truss is formed. The connection system allows for easy swap-in, swap-out of individual modules, which keeps operation and maintenance costs very low. The number of modules that can be connected together is virtually limitless, allowing OEC arrays to be precisely sized to deliver the exact amount of power needed.
So these can be co-located next to other marine renewable installations with a certain compatibility. In fact, the wave devices can reduce the wave action happening on wind tower, so it can actually help offset some of the maintenance costs there. My first approach to this idea was a linear electrical generator, basically a series of permanent magnets on a rod with like poles facing, throwing the magnetic flux off perpendicularly from the travel motion, and that would basically engage a series of counter-wound coils that surrounded the magnets. So the up and down motion, basically magnets going through wire, generated AC, rectified to DC, and series connected within a module and with other modules of an array. So basically it's a quick connect system that's self-supported, neutrally buoyant, and it incorporates a damper plate at the bottom that seriously resists vertical motion. So it acts like a sea anchor, basically, and that helps with mooring costs. So it took a while. I was in college when I invented this, right before that accident I mentioned, and was able to do a special study course after the accident to construct these units for my degree project. Then I reconstructed them after school and made the diodes and rectifiers on the upper right, you might see there, and tank tested 3 units in very small waves, pretty much about this tall, but all 9 of the buoys generated electricity from those small motions you see, and basically it was all combined together at a single pair of output terminals. So I did discover something innately wrong with the linear generator, and that is that it stops and starts every half cycle. So I went linear to rotary, and with a flywheel and a flywheel effect feeding into a commercial generator, it also, it received some testing with a full-scale breadboard, the smallest full-scale, and it had a wave simulator on it. And we got some data points that we were able to use to improve the operation. But again, discovered using wave energy to spin flywheels is a waste of energy. Why not actually get the flywheel effect in the generator itself? So where we are now is a counter-rotating generator. So we have the up and down motions of the buoy, and that basically The major portion, buoyancy force, spins the larger outer portion of the generator one direction, and then the gravity force coming down spins the opposite portion of a generator, the opposite direction. These are permanent magnets. So when these permanent magnets counter-rotate relative to each other, the flux increases, flux rate, and therefore we get more power output with fewer components. We don't need as many bearings, et cetera, to get more power out. And the lower right image is just to show the potential scale of some of these generator rotors. And basically it fits inside a buoyancy chamber that has a ballast control inside. When I started, these machines were dumb. Now with all the sensors and electronics available at low cost, it's a very intelligent system that can actually tell the other modules around it what it is doing and what they need to do. For example, to release and or take in some seawater to adjust the ballast of each module. But these modules are interconnectable by snap-fit connections. And large parts are designed to be close-packed stacked, which enables more units to be transported or stored in a factory or on a ship. Other parts nestle together, and then they can be finally assembled almost at site. Other parts, like the buoyancy chamber, might be factory sealed and guaranteed because of all the electronics in them. These modules form up into triads that can be either linearly composed for towing out to a site and then side connected together, or they can be connected in other ways, but basically they form an octet truss. What is going on in the oil and gas industry and others is a investigation of seafloor architecture, and there's some great technologies coming along, getting much more efficient with, for example, high voltage direct current transmission on the seafloor, and you see in that upper right image some gas storage tanks on the seafloor, which is very interesting in terms of if we're going to do electrolysis of water and produce hydrogen, that might be a likely place to store it. If there's an explosion, it's not really a problem. The mooring system there is the idea of having singular lines at the seafloor where it's the most expensive to deal with maintenance. We have the least amount of materials. These modules on a larger scale can form separate groupings that together form a sensor web that can tell a target module what is required in terms of adjusting its generator properties just before the wave hits the buoy, so that the buoy is following the wave but mostly fully submerged. And if we apply wide area wave mapping, we can predict what will happen to an individual unit up to 8 days in advance, and that's very helpful with pricing and things like that. So the things that we have to worry about or be aware of are marine protected areas, vessel traffic, where are the locations of coastal high voltage direct current lines, and then on that lower right image you see some red dots. Each of those represents 1% humanity, and potential locations for wave energy arrays. A partial study for India shows their electric lines and the gas lines, and if we're producing hydrogen for the gas, and basically it's trying to find some near-shore locations to come on in. Now, Buckminster Fuller, who I mentioned earlier, came up with this map and an integrated world electrical grid, so the daytime use in one region is offset by the nighttime lack of use in another region, very efficient for power management. I've taken that map and put an OWEB grid on it, and basically there are now wave reporting buoys all over the world. Use those reporting buoys to predict what goes into the OEC and what kind of power comes out of it. Taking that information and applying it now onto Google Earth, which has been a very amazing study because it gives all kinds of data that you just cannot get on a map in 3 dimensions. And so I'm still in process. This has taken about 1.5 years so far on free time to actually plot this, and it's still in process, but it's about 90% complete now with just the grid, and there'll be other studies. Thank you very much.